events, cause and effect. We analyse what went right and what went wrong, as we discover that many outcomes can be predicted, planned for, and even prevented. I'm John Chidgey, and this is Causality. Causality is part of the Engineered Network. To support our shows, including this one, head over to our Patreon page, and for other great shows, visit engineered.network today. Kipton. Time for a change. On Saturday, the 18th of April, 1891, just outside of Cleveland in Kipton, Ohio, a crash between two trains would change the way railways were coordinated and the importance of timekeeping forever. It's referred to these days as the Great Kipton Train Wreck. In a time where electrical signalling was in its infancy, telegraph and station operators tried to keep track of train movements relative to a schedule and the clock. The Lakeshore and Michigan Southern Railroad ran several services in Ohio, including mail trains and passenger trains, with trains predominantly dispatched from nearby Cleveland. Late Saturday afternoon, on the 18th of April, 1891, near Kipton Station, 40 miles west of Cleveland, Ohio, the Lakeshore Fast Mail Train No. 14 was traveling eastbound, while the Toledo Express No. 21 was traveling westbound. The Fast Mail No. 14 consisted of 3 mail cars and 2 parlor cars. The Toledo Express No. 21 consisted of 5 coaches and 2 baggage cars. The main line between the intervening stations was primarily a single track with several sidings or bypass lines at key positions along the route to allow one train to pass while the other proceeded unhindered. The normal running time between Oberlin and Kipton stations was approximately 11 minutes and covered 4.7 miles, which is 7.5 kilometers. The running time between Wakeman and Kipton was approximately 6 minutes and covered 5 miles or 8 kilometers. The fast mail train only stopped at Kipton by special request for drop-offs or pickups, and on this particular trip, none were requested. Mail bags were thrown from the train as it passed, and pickups were done via an extendable wooden arm with a mail bag for collection dangled beneath it. The passing train would grab the mail bag with a hook as it passed. All of this saved significant time and allowed the mail trains to deliver mail far more efficiently. In addition, the fast mail trains were generally given priority, and passenger trains were requested to allow these trains to pass as priority on the main line. In the United States, these were referred to as RPOs, or Railway Post Offices, where sorting of mail was done on the train to ensure that no time was wasted waiting to be sorted at a traditional general post office in the next town. The schedule had the Toledo Express No. 21 arriving at Oberlin Station at 4:38 p.m., arriving at Kipton at 4:49 p.m. at the switch track, exiting the Kipton switch track and entering the station proper at some time during 4:52 p.m., once the fast mail train had safely passed by. This would allow 3 minutes for the number 21 to fully enter the bypass line, allow the fast mail to pass, and then exit the bypass line and arrive at the station proper. The schedule had the fast mail number 14 arriving at Wakeman Station at 4:45 p.m., passing Kipton Station right on 4:52 p.m. At 4:44 p.m., the Toledo Express number 21 was reported arriving at Oberlin Station, that's one station east of Kipton, approximately 6 minutes late. At 4:45 p.m., the fast mail train, heading for it as well, was reported at Wakeman Station, one station west of Kipton, heading east, precisely on schedule. At 4:46 p.m., the number 21 was reported leaving Oberlin Station, but it was now running 8 minutes late. At approximately 4:51 and 45 seconds, the westbound Toledo Express was slowing down as it approached the siding to allow the fast mail train to pass. At 4:52 p.m., the switch known as a crossover switch, which was 312 feet or 95 meters west of the station and used by all westbound trains when other trains needed to pass, had its position changed, which also changed the semaphore position to signal eastbound trains. At this time, the Kipton station operator reported that the fast mail number 14 was approximately 1,000 feet or 300 meters from the station, approaching at speed, with the signal semaphore about 100 feet or 30 meters in front of them. The prevailing wind direction and smoke from the fast mail number 14 may have obscured the semaphore from the train's engineer. In addition, there were 2 sidings, one of which was a spur line, but both had been filled earlier with freight carriages from other trains, such that 75 feet west of the passenger house to a point 600 feet east had broken visibility for trains coming from either direction on the main line, as the tracks had a gradual curve through the station. Not seeing the Toledo Express number 21, the fast mail number 14 put on a full steam and opened to 45 miles per hour, or 72 kilometers per hour, as was normal practice running express through Kipton Station. With approximately 500 feet to spare, the fast mail number 14 engineer spotted the near stationary number 21 directly ahead of it and applied its brakes. At 4:52 and 30 seconds approximately, the trains collided head-on with the fast mail number 14 travelling at approximately 40 miles per hour, 64 kilometers per hour, and the number 21 effectively stationary at time of impact. The impact occurred directly in front of the Kipton station and depot. The force of the impact sent passengers hurtling towards the front of their carriages. Seats were torn from the floor of the parlour cars. Shrapnel from the crash injured several bystanders on the nearby platform, including a child playing and waiting for the train on the platform. The engine of the Toledo Express number 21 was knocked squarely across the tracks, and the fast mail number 14 pointed upwards in the air, resting on top of the other engine. The first and second mail cars crumpled like an accordion, and being wooden, disintegrated into small fragments. The third mail car crashed into the first 2 and rolled onto the station platform, breaking some of the station windows in the process. The wreckage ended up piled higher than the roof of the depot building. Once the dust had settled, at about 7 p.m., the wreckage and surrounding areas had been scoured for survivors, and all the people had been cleared from the site. And by 9 p.m. that evening, the wreckage had been cleared from the tracks, though significant damage took longer to repair. The collision had killed 8 people on impact, 6 of them postal clerks working on the fast mail train. The engineers on the number 21, Edward Brown, Charles A. Topliff. The postal clerks on the number 14, Frank Nugent, Charles Hamill, F. Clement, John Bowerfield, Charles McDowell, James McKinley. And in addition, the fireman, also from fast mail number 14, C. Starkey, jumped from the train and died afterwards from his injuries. 2 others were seriously injured, however both recovered. The investigation into this incident was head up by M. J. McInerney, and he prepared a report for the then Commissioner of Railroads and Telegraphs. The freight carriages on the 2 sidings had prevented the engineers from both trains from being able to see each other until they were, theoretically, 900 feet apart at best. Even then, the line of visibility was partially obscured, and it wasn't able to be determined that they actually saw each other's trains even at that distance. Had the fast mail number 14 seen the stationary Toledo Express number 21 from 900 feet away, at the speed it was travelling at the time, a collision was still highly likely, although the severity of that impact would have been reduced. In the investigation, it was determined that this was a contributing factor, though having clear visibility or having paid more strict attention, even at 900 feet, wouldn't have prevented a collision entirely. Conductor Daly testified that he arrived at Oberlin at 4:41 p.m. and left at 4:43 p.m. by his watch, 5 minutes late. Conductor Daly also testified that he made up 4 minutes between Oberlin and Kipton, arriving at Kipton at 4:50 p.m. Given the maximum speed of the train and the grade it had to traverse, this is not possible. Conductor Daly also testified that he went to the engineer at Oberlin and asked if he could make it to Kipton before the fast mail number 14 arrived, and the engineer said that he could. The investigation found conductor Timothy Daly and engineer Emery Bacon had an error of judgment on the Toledo Express number 21, as they had decided to leave Oberlin Station with insufficient time to reach Kipton Station. But why would the experienced people make such a mistake, as they had travelled that mainline section many times and knew it quite well? Additional scrutiny of Emery Bacon's pocket watch and the times testified by Timothy Daly were out by between 3 to 4 minutes of those testified by the Oberlin operator. Bacon's watch was located 4 days after the incident occurred and was stuck showing the time at 4:41 and 30 seconds. The watch had not run down, it was merely jammed. It can't be proven whether it jammed upon impact following the collision. However, further investigation determined that the watch in particular had been dropped in a muddy puddle earlier in that day. At that point, the watch had stopped, and after some cleaning and prodding by Emery Bacon, it began ticking once again. The engineer cleaned it off and went about the next leg of the journey without realizing his watch had lost about 4 minutes of time in the process. Hence, when asked what time the Toledo Express had left each station, the testified times were correct as per the timepiece in use on the train, which explains why they thought they had just enough time to make it to Kipton before the fast mail train came through. They knew they were running late, just not as late as they actually were. The recommendations passed down in the initial investigation centered around adding more time buffer for trains that needed to stop and pass when they met in the timetable. Regulations regarding the engineers' timekeeping practices were noted as well. However, the fallout from the pocket watch came to light after this. A group of senators involved in assessing the aftermath of the incident were staying in downtown Cleveland and happened upon the shop of a jeweler and watch repairer by the name of Webster C. Ball. On display was an impressive chronometer, and the senators inquired more into Ball's expertise. In 1883, when standard time was brought in by law, Ball had been the first watchmaker to implement accurate timekeeping for the city of Cleveland and was well regarded in the city. The general superintendent of the line then commissioned Ball to review the railroad timekeeping rules and regulations and nominated him to be the railroad's chief time inspector. Ball's investigation concluded that railroad employees weren't observing any time and watch standard, and with many engineers simply using their preferred timepiece, often with questionable reliability and even readability. Hence, in 1893, Ball established the set of railroad-approved standards applicable to watches used by railroad workers. Watch manufacturers were requested to produce railroad watches satisfying the standards, and those that didn't comply were banned from use. The main specifications for the railroad watch from that point were a 16 or 18 size movement made in the United States. This is a measurement of the plate diameter of the movement. 16 is 2/3 of an inch, and 18 is 3/5 of an inch. Minimum number of joules is 17. Joules are hard minerals applied to the mechanics of the watch that prevent wear and tear, either at pivot or collision points inside the mechanism. The joule count is generally considered to be a direct indication of the quality, reliability of the watch. Tested to at least 5 positions, meaning when you test the watch's functionality is tested in 5 physical orientations at a minimum. Those included dial up, dial down, as in face down on the table, or in vertical or hanging positions. Pendant up, sometimes called crown up, pendant right, and pendant left. The watch itself must have an error of no more than 30 seconds per week. Watches that fail to satisfy that error limit must be readjusted and reinspected. This accuracy specification in particular, a deviation by no more than 30 seconds per week, was very, very strict for the day. The watch must be operable between a temperature of 40 degrees Fahrenheit and 100 degrees Fahrenheit, which is 4.4 degrees Celsius and 37.8 degrees Celsius. The watch must have a white dial with black Arabic numerals and thick hands. It must be adjustable by the second and encased with our cover. The detailed specifications ensured that the railroad workers could check the time correctly and in an instant in the field. Compared to other watches of the time, railroad watches also required higher air tightness, greater durability against vibration, and superior overall longevity and reliability. Because The reality of their operational environment was that they had to withstand high temperatures and constant vibrations that engineers were exposed to when stoking a locomotive boilers with coal. Today, the tiny village of Kipton has long been bypassed by the railroad, and all that remains of the site where the incident occurred is a park, where there is a historical marker that describes the event. Although the date noted on the marker said it was on the 19th, it was actually the 18th, because in 1891, the 18th of April was a Saturday. So what do we conclude from this? The decade from 1890 to 1900, 80 mail clerks were killed and 2,000 were injured in train wrecks. The US Postmaster General pushed for mail cars to be made from stronger metal frames to protect mail workers on RPOs in the United States. A sensible enough request. Webster Ball and his accurate timepieces became legend and led to the expression, "get on the ball," with reference to the accuracy and dependability of a Ball watch. Recently, the expression's been trimmed to simply be on the ball, meaning hardworking and attention to time and detail. The improvements thrust upon timepieces as a result of this incident, as well as industrialization leading to more trains more often crossing time zones as they traveled, led to an inevitable outcome. Accurate timekeeping matters. From an engineering perspective, the lessons from this incident have been borne out in time. But at that moment in time, whether you think Ball was simply pushing his own business and capitalizing on a need he helped to specify and create, you can't argue with the result. Less incidents like this and a drive towards mass-produced, highly accurate individual timepieces benefited the whole world in a time when the world was shrinking faster than ever before. And the realization that time, and in this case, only 4 minutes, can be the difference between arriving on time or arriving at all. If you're enjoying Causality and want to support the show, you can, like some of our backers, Carsten Hansen and John Whitlow. They and many others are patrons of the show via Patreon, and you can find it at patreon.com/John Chidgey, or one word. Patron rewards include a named thank you on the website, a named thank you at the end of episodes, access to pages of raw show notes, as well as ad-free, high-quality releases of every episode. So if you'd like to contribute something, anything at all, there's lots of great rewards, and beyond that, it's all very much appreciated. Causality is part of the Engineered Network, and you can find it at engineered.network, and you can follow me on Mastodon at Chidgey at engineered.space, or the network on Twitter at engineered_net. This was Causality. I'm John Chidgey. Thanks so much for listening.